Hello, in this presentation I will introduce you the mechanism of exceptions. This is a way to handle errors that is available in many programming languages like Java. Right, so in this set of slides we will give you an introduction on this exception mechanism, the working regime, types of exceptions, how to create new types of exceptions, how to handle them, and we will finish with some examples. So what is an exception? An exception is basically an event that signals an error. And the way to signal that error is by throwing an exception. An exception is an object, and throwing the exception interrupts the normal execution flow of the program. Exceptions can be used to signal any kind of errors. For example, errors relating to data type conversion, errors related to reading from a disk, or device failures, or programming errors. You can define your own type of exceptions that will depend on the domain. For example, you can design exceptions to signal that the password does not follow some policy, or that a certain age is below a certain threshold. To better understand what is the usefulness of exception, we will start by looking at a simple program that reads from a file. We will assume that we don't have the mechanism of exceptions, and we will see how to add this error control. So here you have the program, this method to read from a file. You would need to open the file, compute the file size, allocate the required amount of memory, read the file contents into memory, and close the file whenever you finish processing. But here you are ignoring any possible error, but you know that reading from files is specifically very error prone. And if you want to control the errors, you would need to do something like this. For example, here we are using a typical idiom from C, where basically you encode errors in integers or in some numeric type, and then you design a number of error codes for every type of problem that can happen. So you initialize, well, you first of all declare that the method returns an integer, and this integer is used for the error control. Then you initialize the error code, open the file, and then immediately you check if there is something wrong. And if it is, then you set the error code, for example, to -5 and return the error code. If not, then you compute the file size and then you check whether this succeeded. And if it doesn't, then you signal a new error code, close the file, and then check again whether you succeeded or not, and so on and so on. So you see that for almost for every action that you do, you need to check whether it succeeded or not, and then you need to store in the error code a different code depending on the problem that happened. So this is not a very nice code at all, because it is mixing the control of the errors with the normal execution flow. Instead, this would be the code if you would have a mechanism for exceptions. So you see that the code here is isolated from the errors that it can produce, and what you do is you put the code inside a try-catch block. And then what you do is you add error handlers. These are these catch blocks here that you see. They have as a parameter a type of error. And then if this error happens, you do something here. If this other error happens, then you do something else here, and so on and so on. So you see that the normal execution flow of the program is much more readable, and what you do is you separate the control of errors from the normal execution. So then, what is an exception? Well, an exception models an error, and an exception is just an object of a class that inherits directly or indirectly from exception typically. So the information that this object contains is basically the error type, some message, and then the attributes that you would like to put in that object. You can signal exceptions, you can raise exception using throw, like it is illustrated here. So exception is a standard Java class to signal exceptions that of course you can subclassify, but whenever you find an error of some kind, you can raise this exception by throwing an error of this kind. So you see here I'm invoking the constructor of exception, I'm creating an object, and then this object will interrupt the normal execution flow, so the program will not continue from here, but it will look for an exception handler either in the same method or in a method that call the method that is being executed. Here you can see how we organize the code. So here we have the try block where you put code that can raise exceptions. And then for each exception type that can be produced in the try block, you add a catch handler here. You see we have n number of different exception types. You normally would put all these exception types from more specific exception types to more generic exception types. And optionally, you can add a finally block. The finally block will be executed independently of whether there is an error or not. If there is no error, I execute the try and then I will execute the finally. If there is an error, for example, let's say an error of type exception type 1, I will jump from the moment this exception is generated, I will jump to this catch block here, and after executing this block here, I will continue and execute the finally. The finally block is mostly useful to deallocate resources, for example, to close files and things like that. Here you have another example. We have a try block here where I'm invoking method f from object opt, and I declare that this method f throws an exception. So every method that can raise some exception needs to declare it in the signature, and this is done by adding throws and then a list of all the exceptions that the method can declare. Of course, normally, typically, exceptions will come in a hierarchy. So you will design a hierarchy of exceptions, typically inheriting from exception. And you can put here an exception class, and inside the code you can throw either exactly this exception type or any subtype. So you see here what we do is we check variable age, and if it is less than 0, we signal an error. We throw an error negative age. What is negative age? Well, negative age is a class for the exception. Here we're invoking the constructor with these two parameters. So if this error is really happening at runtime, if the age is less than 0, so from here, from this point, we will jump to the exception handler here. So here we will jump to this catch because this catch is handling negative age, which is exactly the exception that this method is throwing. Here is another example where we have a class, bank account, which may be blocked, and it has a method withdraw. So it will subtract this amount from the bank account. And here we foresee that we may have two types of errors. One is that you don't have enough funds in this bank account, and the other one is that the account is currently blocked. So if it is blocked, I will throw the blocked account exception, and if the amount is more than balance, then that I will not have funds, and I will throw this other exception. And if everything goes right, then I subtract the amount from the balance. How do I define these exception types? Well, basically exceptions are classes that typically will inherit from exception. You will see later if you study these slides that there are other options, like for example inheriting from runtime exception. This is a full-fledged class, which means you can have a constructor like this one here, you can have parameters like account number and balance to save the state of the error, and this class exception inherits from object. Therefore, you can override methods of object like toString. For example, giving information about the error, the underfunded account, the account number, and the balance of the account. This is another exception that follows the same principle. It extends from exception, it declares an attribute, it has a constructor, and overrides toString. Another thing that is very normal to do is to create a base class for your exception. So instead of having underfunded exception and blocked account exception that extend exception, you would declare a base class, typically abstract, which will be the base class for all the exceptions in your application. Right, so this is an example of code that is using the method withdraw. Because this method can raise two types of exception, I need to put here two catch blocks. And because an error will happen at runtime, namely that I don't have enough funding in the account, then I will basically execute this code here, which will print the exception by calling toString, and this is basically the result of the execution. Another possibility is not to put a try catch block, but if you don't do it, you need to make the current method throw the exceptions that it doesn't handle. So for example here, what we do is we say, okay, I know withdraw can raise two types of exception. I'm not going to put here the try catch blocks. Therefore, this method will throw these exceptions if they happen at runtime. And because this is the main block, what will happen is that there is no other method that is invoking this one here, and therefore the program will terminate, printing in the error console the stack trace when the exception happened. Right, so overall, what's the working scheme of an exception? Well, we start the execution in the main. From the main, we may call a method that calls another method that calls another method, and then at some point in this method here, an exception may occur. So immediately, what happens is that the virtual machine will look for exception handlers, for catch blocks that are able to handle that exception. If that catch is not here, what will happen is that I will go back to this method here, and if this method doesn't have a catch block either, I will go back again to the previous method until I find a catch block. So you see here that the execution will come back to this method because in this method there is a catch block. If there is no catch block, not even in the main, what will happen is that the program will stop, and then the stack trace information will be shown in the error console, as I said before. So you see that overall, a method must catch all exceptions that can be raised from any of the method that it contains, or if you don't put a catch, then you need to declare that the method throws the exception that it doesn't handle. Otherwise, there will be a compilation error. There are other types of exceptions, namely those that inherit from runtime exception that you don't need to put a catch. This makes a lot of sense because there are many programming errors that are also signaled by exceptions. For example, division by zero, null pointer exception, and so on. So you can imagine that it wouldn't be feasible if you need to catch all these possible programming errors. So there are a type of exceptions that you don't need to handle, which typically will inherit from the class runtime exception. Right, so here I will finish this presentation, and I will recommend you to study the rest of the slides by yourself, try to make the exercises, and to respond to the questionnaires. And of course, if you have any question, don't hesitate to send me an email or to write in the forum in Moodle.